Okay, so question 3. Now we have two functions, h and k, are given by h of x equals x squared minus 5 over 2, where x is greater than or equal to 0, and k of x is equal to 4x to the power of 3. So we've got three parts to this question. We've got part A, determine and state its domain of the inverse of h of x, calculate or evaluate the inverse of h of x when x is equal to 1.9, and find an expression of h of k of x, so a composite function of these two functions. So let's start with part A here. Okay, so determine and state the domain of the inverse of h of x. So I like to start out by writing the function. So we've got h of x is equal to x squared minus 5 over 2. So step 1. So step 1, we're going to replace this h of x with y. So y is equal to x squared minus 5 over 2. Step 2, we're now going to solve for x, so we have to do transposition. So I'll take this to the other side, so I'll kind of swap these around the equal sign. So I've got x squared minus 5 over 2 is equal to y. Now the only reason I do this, you don't have to do this, but the only reason I do this is so because I want x on its own. I want x equals something. So I've kind of just put that to the other side. So I've got x on this side of the equals. Just makes things a little bit easier from this point forward. Okay, so the next step, let's take this 2 that's dividing this x minus 5 and take it to the side, and it multiplies this 2y. So we're multiplying throughout by 2 here. So what we're left with is we've got x squared minus 5 is equal to 2 times y. Okay, now we can get rid of this minus 5 from this side. So we can add 5 to both sides. And what we're left with is x squared is equal to 2y minus on this side, positive on this side, plus 5. Last thing we can do is isolate x. We're taking the square root of both sides, so what we're doing is this power of 2 then becomes the square root on this side. So 2y plus 5, and that's the square root there. Okay, so now we have x. Our last step. Step 3 in this process is we're going to replace x with the inverse of the function. In this case, it's inverse h of x. So we're trying to find h to the minus 1 of x. So that's what we're going to replace this with. So it'll be h inverse of x is equal, and we're replacing y in this side of the formula with x. So that'll be the square root of 2x plus 5. Okay. So we found an expression for the inverse of the function, but now let's calculate the domain. So I'll put the domain of the inverse h of x. Well, the first thing, we've got two rules, or two things to bear in mind when we talk about the domain, calculate the domain. We've got square roots and we've got fractions. Here we've got a square root, so we remember that we cannot have a negative sign of the square root, otherwise we'd be then going into the complex domain. So what we need is 2x plus 5 to be greater than or equal to 0. So we need that to be true for the domain. So let's solve this for x. So we take the 5 to the side and it becomes 2x is greater than or equal to, this becomes negative 5 on this side. And now we can have x is greater than or equal to negative 5 divided by 2. So we finish this off by saying x contains all the real numbers. X is greater than or equal to minus 5 over 2. Okay, so now we can do part B. So this is part A. So we've got 1, 2, 3, there's 5 marks there, 4 marks, 4 marks there. 1 mark for this, 1 mark for this, mark for this, and a mark for this. Okay, so now we can do part B. So let's remind ourselves what part B was asking us. Calculate the inverse h of x when x is equal to 1.9. So we're evaluating this formula. So we're taking this formula here that we calculated and we're going to evaluate it when x is equal to 1.9. So we're going to replace the x's in here with 1.9. So h inverse of 1.9 is equal to the square root of 2 times 1.9 plus 5. Use our trusty calculator. So square root of 2 times, and I like to use the brackets here, plus 5. Gives us it in a fraction, s to d, 2.966 to 3 decimal places. So that equals 2.966 to 3 decimal places. Alright, and finally part C. We've got to do a composite function here. So it's asking us to find an expression for h of k of x. So we're finding the composite function here. So the output of k of x is the input of h of x. So what we do, I'll rewrite the formulas down here. So I'll put h of x is equal to x squared minus 5 over 2, and k of x is equal to that's 4x cubed. So what we're going to do here is I'm going to replace this x, if I can do that a little bit better. That doesn't like me using Control Z. Okay, we're going to replace this x here with the entirety of k of x. So that gets substituted into that. So what we'll get is we're getting h of k of x is equal to, well, this x here becomes 4x cubed. So it's 4x cubed, and I'll put that in brackets, and that's squared because this x here is squared, so this 4x cubed has to be squared, and it's minus 5 divided by 2. So let's simplify this. This squared here, we're going to square this 4, so that becomes 16x. And the rules of indices states that when you've got an index raised to a power, we're going to multiply them. So 3 times 2 is 6. So 16x raised to the power of 6 minus 5 divided by 2. And that is a good enough answer.